In this video, we're going to talk about equations in slope-intercept form. The slope-intercept form equation for a line is the y equals mx plus b form. In this equation, m is the slope and b is the y-intercept. For this equation, the x and y are any point that's on the line, the x and y coordinates of that point. So to find another point on the graph, what we can do is use our equation and plug in any number for x and then evaluate the right side of the equation. That will give us the y-coordinate. So now we're going to look at some tables. For each table, we're going to write an equation of the line in slope-intercept form. In order to write the equation in slope-intercept form, we need to identify the slope and the y-intercept for each set of points. So looking at my first one, I can see that I have the point 0, 27 in my table. That's going to be the y-intercept. So when x is 0, whatever the y-coordinate there is the y-intercept. So the easiest way to find b is if it's just given to you directly. Now to find the slope. The slope, remember, is the change in y for each 1 unit change or increase in x. So looking at my table, I'm going to switch colors here. We have the x-coordinate going from 0 to 1. The y-coordinate goes from 27 to 21. So it's going down 6. And as we go from 1 to 2, my y-coordinate goes from 21 to 15, so it's also going down 6. So we're going down 6 for each 1 unit increase in x. And so that means that m is -6. We could also use our slope formula here if we wanted to. So if I picked the top 2 points and said that this was x1, x1 and x2, this is going to be y1 and y2. And then plug into the formula. We would have 21 minus 27 over 1 minus 0. So -6 over 1, which is -6. I could choose either of these 2 points for x1 and x2. I could use the bottom point instead. Any 2 points that I choose, I should end up with the same -6 for my slope. So what that means about my equation is that it's going to be y equals -6 times x. And I'm using the colors here to really show where the pieces go, and then plus b, which is 27. So that's my equation. Let's look at number 11. Again, we have the y-intercept identified easily in the table with the point 0, 4. So 4 is my y-intercept, or b. Now this time, my table isn't increasing by units of 1 for x. It's going from 0 to 3, from -3 to 0. So it's not quite as easy to figure out what the slope is. I could still reason my way through it because I can see that I'm increasing 3 units in x and 6 units in y. Since a line has to have a consistent rate of increase, that means that for each 1 unit in x, I need to be going up 2 in y. Again, we could use the slope formula instead. So if I were to label my points here, I'll choose the second two here for x1 and x2, y1 and y2, and then plug in. We're going to get 10 minus 4 over 3 minus 0, which is 6 over 3, which is 2. So my formula is going to be y equals 2 for my slope, and then x plus 4 for my y-intercept. All right, looking at number 12. Now I don't have my y-intercept nicely laid out in the table, so I have to do a little bit more work to figure it out. So let's see. We could start with the slope. I can see that for each 1 unit increase in x, my y is decreasing 5. So my slope is going to be -5. Again, we could also use the slope formula. I will demonstrate that as well. So if we have x1, y1, x2, y2, when we use the slope formula, we have 15 minus 20 over 5 minus 4, which is -5. Now, to find the value of b, one thing that I could do is use my table to walk backwards. So if I know that it's decreasing by 5 as I move forward, each unit in 1, that means as I move backwards, I can add 5. So I know when x is 2, y is going to be 30. And I could repeat that process until I get back to 0. Another way that I could do it is I could set up my equation with 2 of the points. So if I do it that way, or with 1 of the points. If I do it that way, I'll use my x1 and y1 that I already have labeled. I would plug in 20 for y, I would plug in the m that I found, and I would plug in 4 for x. And then I'm going to solve the equation for b. So what I'm doing is I'm plugging in to y equals mx plus b here. So I've plugged in one of the coordinate pairs for x and y, and I have plugged in the slope that I just found. So 20 equals -20 plus b. And then to get b by itself, add 20 to both sides, so b is 40. So for my equation, it's going to be y equals -5x plus 40. And finally, for number 13, same thing, check and see if I have my y-intercept directly labeled in the table. I do not, because I don't have an x value of 0, so I'll need to find that. And I will need to find the slope. Again, slope here is a little more challenging because I'm not going up by 1, but I could figure it out by dividing. I go up 4 units in x and 12 units in y. That means for each unit in x, I am going up 3 units in y. Or I could use the slope formula. So we'll do that real quick here with one pair of points. And if I choose the top 2 points, 17 minus 5 over 6 minus 2. So essentially, this is just a formula way of writing out what I had just talked through. I'm changing 12 units in the y direction for every 4 units in the x direction, and 12 divided by 4 is 3. So 3 units in the y direction for every 1 unit in the x direction. And then finally, to solve for b, again, I could use my walking back method that I described before. So I would need to walk back 2 from this 2 point to get the y-intercept. So if it's increasing by 3 each time, that means when x is 1, y is 2. When x is 0, y is going to be -1. Or I can use the method that I described before of plugging in. So y equals mx plus b. I'll plug in the top row there, 5 for y, 3 for m, 2 for x, and solving for b, I can see that b is going to equal -1. So my equation will be y equals 3x -1.